All right. First, before we get into anything with the notes, let's go homework expectations, because this unit's a lot different than any of the other 8 we've done. You'll be doing a lot of graphing this unit, a lot of graphing. So I just want to make sure we're all clear. Anytime you're doing an assignment out of the textbook and it says to graph, those graphs are not optional. I have a ton of slices up here you can grab before you leave today. Also, if you take a look in the back of your packet, there's also graph paper back there. No excuses. I got them covered for you. What people have done in the past and they prefer is, look, I'm just going to take a sheet of graph paper from me, or if you have your own, and just do the whole homework on here. All right, instead of going notebook, back of the packet, notebook, my own piece of graph paper. Just do it all on one sheet. Okay, but it's up to you how you want to do it. But when it says to graph, it means graph. Okay, not optional. And also, notice this is an option. The back of your packet is an option, or your own graph paper is an option. What is not an option? Oh, I'm going to do number 5 tonight, and I'm going to do my own little ghetto graph here. Nope, no thanks. No thanks, I'm good. Not in an honors level. Thanks, though. Head over across the street to Eagle. Maybe they'll accept that. Okay, but not here. All right. Okay, let's get it going then. Now that we went over the expectations. We're going to be using this word a lot, transformations. So I want you guys to realize before we start taking notes, what am I talking about when I say a transformation? I'm moving a figure. All right, a figure is being moved. How? I could be rotating it, turning it. I could be reflecting it, flipping it. Translate. Anybody know another word for translate what I'm doing to the figure? They have some on playgrounds. Good. There we go, Tyler. Thank you. Sliding a figure. All right, translation. Or dilating a figure, making it bigger or smaller. Or I could be doing a combination. You know, later on in the unit, we're going to be doing more than one on a figure. So when we say transformation, a figure is getting moved from its original spot. Now, let me give you a new vocabulary term. After I move that figure, if the angles remain the same and the sides remain the same, aka what word am I talking about here? They remain congruent. We have a word for that. So if the two figures remain congruent at the end, we just performed what was called a rigid motion. Okay, a rigid motion. So I take my starting figure, I do something to it, turn it, flip it, move it somewhere, and what I end up with looks just the same as the original, just in a different spot. We just performed what was called a rigid motion. So going back up here, I got 4 listed up here. 3 of them classify as a rigid motion, or types of rigid motions. Anybody want to nominate somebody here? Nick?
Rotation, reflection, and translation.
Nominate one, and you just give me all 3. That's fine. Yes. These 3 up here are considered rigid motions. Why? Am I ever going to change the size of any of these when I do these 3? No. What's not considered a rigid motion? Why not dilation? Changing the size. The side length changes. But the side length changes. You know what doesn't change? Angle measure. There you go. So in a dilation is an example where you preserve angle measure. Okay? The sides are not the same, but the angles are when I dilate. And finally, last 2 new vocabulary terms. I don't want to start saying the original figure, the starting figure, the ending figure, the resulting figure. We're going to name it with 2 terms right now. Whatever you start with, we're going to start calling that the pre-image. That's my pre-image, whatever I start with, the figure, the point I start with. I'm going to do something to it. Reflect it, rotate it, translate it, dilate it, maybe a combination of both. Whatever I end up with, we're going to call that the image. So pre-image I start with, image I end up with. All right? So there are my vocabulary terms. Before we get off rigid motion, just 2 quick examples here. I've done a transformation. I don't know what it is, but I've done some type of transformation that this pre-image goes to this image. Did I do a rigid motion? Whatever transformation I performed, do you think it was a rigid motion? No. Why not? Why would this transformation not be considered a rigid motion here? Brothers?
Because you changed the size of it.
I changed the size. Rigid motions, angle measure, side length don't change. What about number 2? Did it look like I performed a rigid motion there? Yeah. Side length stayed the same. Angle measure looks like it stayed the same. So this is a type of rigid motion. I don't know, what is it? Maybe a rotation and something else, but it's a rigid motion. Today's focus is on a rigid motion called a reflection. We're going to flip over numerous amounts of lines. So today's topic, reflection. We have shorthands in here, right? We have shorthand, symbols, abbreviations. Reflection has its own symbol. Reflection has its own symbol. Its symbol is lowercase r. Well, what if I put uppercase r? You're wrong. That is something saved for further on in the unit. That's why it's not uppercase r. That's already reserved for something else. Lowercase r tells me reflection. And then you're going to see a little attachment to it. Anybody heard of the term subscript? Heard that term subscript? Where do you usually see a subscript? What's up, Kyle?
Underneath it.
Below something, right? Underneath it. And that's exactly what you're going to see here with the reflection. You're going to see a subscript. So let me just put in y-axis right now. The subscript's important because the subscript's telling you the line to reflect over. So 2 pieces. The lowercase r signals everybody reflection about to happen. The subscript, okay, here's the line you're going to reflect over. All right, you ready to do your first reflection? All right, let's do it. Whew. We're going to take point A. We're going to do multiple things with it. Point A is 2, -1, so why don't you throw that on the graph that I provided for you in your notes. 2, -1. Hopefully graphing is not an issue. So there it is, point A. Please look at the top left one. We're going to do that one first. Does everyone see my lowercase r? What's the subscript say? X-axis. So that's telling you take point A and reflect it over the x-axis. X-axis. All right, how do I actually do this reflecting now? Distance does not change when you reflect. I'm going to ask somebody here now, how many units away is A from the x-axis? How many units is A away from the x-axis? 9. 1 unit away. Then you're going to go 1 unit on the opposite side. Distance does not change. 1 unit away. Now 1 unit on the other side of the x-axis. Notation time. I can't call that point A because it's not. I'm not going to call it point B either. Name it something new. Anybody know the notation? How do you name a transformed point? Maddie? I thought you were going to tell me. That's why I... Like this?
Yeah.
All right, I like it. Yep. Anybody know what that's called? What's it called? I guess so, yeah, right? But I don't call it A apostrophe, though. A begins with a P, ends in rhyme. Did you just say period back then? I spotted you the P and said it ended in rhyme. And the kid tells me period. I don't know what else I could have spotted you. Prime, yes. A prime. That's called A prime. Okay, A prime. All right, please don't go ahead of me because I got to show you an honors level situation right here. Do not do this. Don't do this, please. If I connect A prime, what geometric vocabulary word did I just make? That's called a line segment. Good. So when I connect the pre-image and the image, it makes a segment. What line did I just reflect over? What line did I just reflect over?
X-axis.
I would like you to tell me a couple of vocabulary terms what the x-axis is doing to line segment AA prime. It's perpendicular. Those two are perpendicular, and I heard the other one. Bisector. All right, so here's what I need you to get through by the end of today. Whatever line you reflect over is the perpendicular bisector for that segment. Okay, I'm going to do it more and more, but whatever the segment is, the line I reflect over is the perpendicular bisector. One doesn't make you great. Let's reflect some more. Go back to 2, -1. Now go to the bottom left. Now I want you to reflect it over the y-axis. So let's take 2, -1, reflect it over the y. How many units away is A from the y-axis? 18? 2. So everyone go 2 units in the other direction. Now I'm still going to call this A prime because it happened on A. Not going to put 2 there. I'll show you when we put 2 there. It's still going to be prime because I performed it on the original. And what are your coordinates? I should have wrote that in. 2, 1 up here. What are your coordinates for A prime now with a reflection over the y-axis? 12. What are my coordinates now? Yep. Everybody take a look on my diagram. Let me connect that segment, AA prime. Bless you. What line did we reflect over? What's the y-axis doing? Perpendicular bisector. Every time. And I'm going to keep doing that at the end of every problem. Go bottom right here for me now. Bottom right. Now I want you to reflect over the line. Oh. Y equals 2. You've probably graphed this so many times in your life you just don't remember. Anybody know what type of line that is? Y equals 2. Oh, I just have my graphing calculator handy here. Y equals 2. Ready? What type of line? Don't tell me straight. They're all straight. Horizontal. Thank you. Anytime you graph y equals just a number, that is a horizontal line. All right, so here it is right here. Y equals 2. There it is, drawing it in. I want you to reflect point A over that one. Okay? Distance doesn't change. I don't care if it's not the Y or X axis. Count the distance and match it on the other side. Distance remains the same. How far is A from Y equals 2 now? 25. How far away?
3.
1, 2, 3. So we're going 3 on the opposite side. 1, 2, 3. Here's A prime now. And what is that point? 18? 2, 5. All right, I'm doing it again. Take a look. I'm doing it again. See that segment? See the line I reflected over? Perpendicular bisector. Again, line of reflection acts as the perpendicular bisector. And I wrote that in the wrong place for the second straight class. One job. Okay, everyone's good. All right, I'm going to just, because I can, I'm going to clear out that. 2, -1. All right, now we come to a big issue, the last one. Reflect it over the line y equals x. First, what does that line look like? Ready? Y equals x. Seen that one before, right? Seen that one before. Looks like this. No counting here. Counting only works for horizontal and vertical lines. No counting. So what I'm going to have you do is simply remember the rule. If it's over the line, y equals x. So a reflection over the line y equals x, I am going to do the following. This is one of 2 rules I need you to memorize, and that's it, just 2. If you reflect over the line y equals x, Flip the coordinates. That's it. Your y becomes your x, and your x becomes your y. Flip the coordinates. That is the rule. Flip your coordinates. All right, so where would A prime end up if I flip the coordinates of A? New coordinates, 10?
2, -1.
2, -1. That is the original coordinate, Zach. Thank you.
Oh.
Yep.
-1, 2.
Thank you. -1, 2. Oh, I'm not done. I'm going to keep doing it. So, does it look like it's been flipped over? Yep. And ready? Relax. It's the perpendicular bisector of it. All right. Look, I love it. You can do points. Great. That's not where I need you to be. I need you to be able to reflect actual shapes, aka triangles in this class. So go ahead, graph triangle ABC. I'm going to walk around and see you guys reflected over the y-axis. Y-axis. And make sure you name your new points correctly. Y-axis, Y. I get a few kids giving me the x-axis. Y-axis. If you haven't, label the points, please. A prime, B prime, C prime. You don't need to, it doesn't say state them, so you don't need to tell me what they are, but I want to see the A prime, the B prime, and the C prime. 1, 2, 3, 4, 1. No issues? Looks good? I want to reflect a couple other things, and then that'll be it. All right, let's do this. Point X, everyone, 0, 5. I always pick 0, 5 every year because I'm interested where you're going to put this. You're going to put it on the X or the Y axis. Where's 0, 5? Where is it? Y-axis, thank you. Oh, X equals 2. What type of line do you think we're reflecting now? Vertical line. Y equals was horizontal, X equals vertical. So I'm going right through X equals 2. Vertical line going through 2. Go ahead, count the distance and match it on the other side. Distance remains the same. And let me know what X prime ends up being when you count it. 2?
2, -5.
2 negative,
Oh, right.
way down here?
5.
2, 5 on the line?
Oh, 4, 5.
Okay. Third time's the charm.
Yay.
4, 5. Please read everything carefully, because now we're getting to the point is, all right, now I'm doing a part B, a part C, or part D. What do you want me to reflect? Do I go back to the original or the one I just reflected? So look at part B, reflect X prime. So I'm not going back to original 0, 5. I'm going back to 4, 5. Please read carefully, and I'm reflecting it over the line Y equals -3. What type of line is that one? Horizontal now. And I did this on purpose, and I love this. I love it. Oh, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I run out of graph. And darn it, you're in honors. No way am I walking around seeing this business. Oh, let me extend the graph here and do. No. Use some math here. Use some math. You don't need to extend the graph to figure out where you end up. It's 8 units away, and you're at y equals negative 3. 8 more units away. Whew. I ran out of graph. Okay, who cares? Who cares? All right, where do you end up after you take x prime and reflect it over y equals negative 3? 8. Where do we end up?
5, negative 11.
So we bounced over one.
Oh, sorry, 4, negative 11.
4, negative 11. What do I call this point? X double prime. Yes, double prime. Now do you see when you use the double, if you reflect the single prime? And if I do something to this, I call it triple prime, and we'll get there eventually. All good? All right, so we reflected points, triangles. How about a line segment here? And I have a new reflection here at the end we got to talk about. So line segment FG, F is 3, 0. G, 4, 3. Y equals X. That's the rule I have to remember. It's not counting. It's the rule I have to remember. Oh, he's asking me to reflect over Y equals X. Here's what I have to do to the coordinates. I'm not counting. So F prime, G prime. Oh, 19. How about F prime when you're ready?
0, 3.
Flip them. Remember the rules, flip them. And then how about G prime? 3.
4, 3.
That is G. You and Zach should hook up here.
3, 4.
3, 4. Yep. Now, actually, let me go to this point here. Congratulations, man. You reminded me of something. Is it possible for a point to remain the same after a reflection? Could that happen? When? If you reflect over. Look, let me go back here. Here's my point, and I say reflect over the line y equals negative 3. Is it going anywhere? Okay, so remember that a point doesn't have to move. It could remain at the same spot if your point's on the line of reflection. All right? All right, so let me graph these real quick here and then go to my last new reflection. 0, 3. What's that? F prime. And 3, 4. G prime. Take a quick look. Y equals X. Looks like we reflected over, right? And, yep. Look, F prime. I connect them. What's Y equals X doing? Perpendicular bisector. And same thing if I connected G and G prime. All right, ready for my last one here. Now I want you to reflect over this line. Y equals not X, but negative X. Thoughts on what that line looks like before I throw it on my graphing calculator? What do you got? The other way, right? Going downhill now. Yeah. All right. So we know, is this horizontal or vertical? No, right? So counting is out. I can only count distances when it's horizontal or vertical I'm reflecting over. This is not. So this is the second and last rule I need you to remember. Y equals X, and part A was flip the coordinates. I think you guys could maybe guess what this rule is. What do we think? Anybody want to take a stab at it? Max? Okay, that's halfway there. change signs. Yep, change signs. And, because remember, this is just a version of y equals x, so I'm still going to also have to flip the coordinates. All right, change the signs and flip coordinates. So let's go back to part B. Reading. What am I reflecting over y equals negative x? My original or the one I did in part A? The OG, the original. Good. So I'm still going to call that f prime and g prime because I'm going back to the original. Flip and change the sign. All right, what's my f prime then? Woo. Oh, 27. Going deep. Yep, flip them and change the sign. G prime, 26. Good job. There it is. And -3. Yep. And if you take a look, I probably shouldn't have used white there. Now it definitely looks like I flipped the original over there. And connect FF prime. Perpendicular bisector now. Okay, that line of reflection. All right, one more thing to do. And that is, you guys find the line of reflection. Instead of me saying reflected over this line, what I've done here in the last problem is I've given you the pre-image triangle ABC. I've given you guys the pre-image, A prime, B prime, C prime. All right, now it's on you. Where did I reflect over? So the distance always stays the same from A to A prime, B to B prime, C to C prime. What line must I have reflected over? And I'm not going to do a diagonal one on you. That's for Monday's honors reflection. Make sure you name that sucker correctly. Just don't draw it in and say this line. Give a name to it, equation of it. Go ahead and draw it on your graph first, but then say, all right, what is the equation of this line? Hopefully we're all in agreement. It's this line right here. All right, what's the name of that line? I'm going to do a reflection. What would be my subscript here? What's the equation of that line? 28. Finish strong, Tyler.
X equals 3.
Thank you. Not Y, X. Vertical lines are X. Vertical lines are X. Questions? Need a slice of graph paper. They're all up here. Okay? And if it says the graph, not optional. Let's get it going in the 10 minutes we have left.